Okay, welcome guys. We're looking at trigonometry today and solving trigonometric equations. Some nice simple ones here. We're working between 0 and 360. So I'm just going to draw my sine graph over to the side here. This is what my sine graph will look like, roughly. Okay, we know that there's a peak here at 90. This is 180. This is 270, this minimum, and then we've got a 360 here, and of course 0 over here. That's our sine graph. Okay, you want to memorize that. Now, what we do to find x is our first step is to go x is equal to the inverse sine of 3/5. And this will give us our principal value. So you go inverse sine 3/5, and you'll get 36.9 degrees, rounded. Now, what you then do, because we've been given it 0 is less than equal to x is less than or equal to 360. That's our range. So we've got to find everything in the range between 0 and 360. So I've got a 36.9, which is, say, roughly about here. And if you look carefully, there's going to be another result in the range. And by symmetry, if this is 36.9 from 0, then the second one is going to be 36.9 from 180. So you go 180, take away the exact answer that you got before, and that should give you 143.1 degrees. So those would be my two answers in that range. Now, let's move on to the next one, which is an example of a cosine. Now, the cosine looks a bit like this, where this is 180, this is 90, this is 360, this is 270, and of course this is 0. Now, you know with straight away a negative 2/5, you're going to get a result in between. So this is our negatives, isn't it? So it's going to be here and here somewhere. So what we do, therefore, is we go the inverse cosine of 2/5 is equal to x. And so x is equal to, now watch what happens here. Oh, sorry, that should be negative 2/5. So we go inverse cosine negative 2/5, and you'll find you get 113. So that's about here. And then we know that there should be another one out here somewhere. Now, if this is 113 this way, then this one must be 113 from 360. So we go 360 minus the exact answer we got previously, and we should get 246.4 degrees. Now let's move on to the tan question. Now, a tan graph is a little bit different. It's got some asymptotes here. So it will look like this, with an asymptote at 90. So that's 90. And then it will come up like this, and then go up like that, where this is 180. And we've got another asymptote here, which is, of course, 270. And then we've got there, and it meets there at 360. Okay, and of course 0 is here. Okay, so to get x, we go x is equal to the inverse tan of 3.4. And when we chuck that into our graph, inverse tan 3.4, I'm getting 73.6 degrees. Now, 3.4 is somewhere up here. So we've got one here, and you can see that we've got one here. Now, with tans, all you need to do is you see that the pattern repeats every 180. So we just add 180 to this, and we're going to get 253.6, and that's that. The last type is a type where it's kind of like a quadratic equation. So what we want to do, let's just draw our sine graph again. Here's our sine graph. Well, it's not very well drawn, but you get the general idea. This will just help us. We've got a 270 here, we've got a 90 over here, and a 0 here. Let's factorize this out as a quadratic. Minus 1, minus 1. I think that's factorized. Okay, so you've got two options. In the first bracket, you've got sine x is equal to 1/2, or in the second bracket, it's equal to 1. So let's do the first one. X is equal to the inverse sine of 1/2. And that gives me 30 degrees. So I go, all right, I got a 30 here. If it's 30 from 0, we know that the other one is going to be 30 from 180, so that's 150. And with the next one, where does it equal 1? Well, I'm not even going to pop that into my calculator because I know that it happens here, and that's the only place it happens on the whole sine graph between 0 and 360, so that happens at 90 degrees. And so those are my 3 answers there. Let me know how you get on with these. If you need any help, we can chat about it on Zoom. Happy to do that. Let me know. Take care.